Everybody there?
Yeah.
Page 3 of your homework at the bottom. So this is a review of the warm-up and with the Lewis dot structure of when these things react. We're going to add a few things to it today. Okay, you ready? So, where does lithium chlorine look familiar? Why does that look familiar?
The warm up.
It's a warm-up, guys. Come on. It's a warm-up. Yes?
Yeah.
Okay. So just like if you were gone, didn't understand the warm-up, how we got it, what we were doing, this is the same thing. So this is what happened, right? Little reteach. You write down lithium, and then do the Lewis dot structure of lithium. Yes? Yes? Do chlorine. Lewis dot structure of chlorine. It has 7. There you go. Then you're going to show the transfer of electrons from one to the other. We know that lithium has 1, it wants to get rid of it. Chlorine has 7, it wants to gain 1. So there we go. When that happens, lithium becomes happy because it now has an empty outer shell, but its overall charge is going to be a positive. In this case, a positive 1. We don't need to wrap it 1 because it's implied. Chlorine, when it gains 1, it will become happy, so we put the happy brackets around it. And it's happiest at a -1 charge. That's where that diagram came from in the warm-up. Everybody following that? That's review. The new stuff. What is your chemical formula from what we did over here? So what is a chemical formula? H2O, CO2, C6H12O6, CO, carbon monoxide, right? You guys have heard this before? These are all chemical formulas, right? It's the symbol with numbers next to it that tell me how many there are of each. What do I mean by that? If I have H2O, right? How many hydrogens do I have?
2.
How many oxygens?
1.
Right? Remember I said the implied 1? There's an implied 1 there, right? If it was 0, I wouldn't have an oxygen there. If it were 2 or more, I'd write that number down. But in this case, it's just H2O, right? If I have C6H12O6, that is a chemical formula. It tells me how many of each atom I have per element, right? So how many atoms of oxygen do I have?
6.
Yes?
Yes.
How many different elements do I have?
3.
3. Each capital letter is a different element. That's a quick review, okay? So when I come over here to write my formula, I look at what I did right here, right? The first thing that you need to know is we always list metals first. Metals always come first. Your cations, because cations are metals, cations are always listed first. All right, they're always named first, right? So I look here, which one's my metal? Which one's my cation?
Lithium.
So over here, I'm going to put Li, lithium. Now we need to count lithiums, right? Because I can put a count, I need to know how many I have of them. How many lithiums did I write down?
1.
So how many should I write here?
No.
Nothing, but there's that implied 1. Yes? How many chlorines? So I write down, my next one is chlorine. How many chlorines do I have? 1 chlorine, right? So do I need to do anything right now?
No.
I'm done. Right? That's the chemical formula when lithium and chlorine react, right? The last thing is you're going to add another column over here of your overall charge of that new compound that we just created. Right? So I'm looking for the overall charge. Yes? Right? What is +1 -1?
0. Neutral.
0. And that's a good thing. Every compound that we form this year should end up being 0. Because if it's not 0, that means it has some electrons that are unpaired, that don't complete the octet, and so that's an unhappy compound. That's not a good thing. We are always going to try to form, and we always will form, happy compounds. Yes? All right, so that's why that charge is important. Okay, we're going to come back to that later in the lesson, right? The next one gets pretty much involved. So, what I'm telling you right now is you have to follow and do what I do for this next one. This is about as hard as they get, okay? if you stare off into space for the next 30 seconds to a minute, you're going to say, what in the world just happened? The answer up here is going to look like a hot mess unless you follow along at each step. And then you know where all these arrows are going, where all these electrons are going, and things like that, okay? You need to watch this. Ready? Beryllium and nitrogen. What happens when they react? More specifically, what happens to the electrons when they react? Let's show it. Beryllium starts with the Louis dot structure of 2 dots. You all agree with that? Yes? Nitrogen starts with how many? 5. Like that. Would you all agree there? Do what I do. Right? So, beryllium, gain or losing electrons. What's the easy thing to do? Lose. It wants to get rid of them, right? And in this case, it's going to give them to nitrogen, who wants to accept them, right? So it's a good thing they found each other, right? So here we go. Beryllium will put one into that spot, and its other one, let's say, puts into that spot, right? By doing that, did I make either one of them happy? Which one is happy right now? So what do we need to do to it? Brackets. Put the happy brackets around it. Because I put happy brackets around it, it's formed an ion. So every ion has to have a what with it? A charge. What is the charge to this beryllium right now? The ion is no longer a ground state, it's an ion. So is this a happy compound right now?
No.
What's wrong? Nitrogen's still upset. Yes? So now what do I need to do? Because this is not, we need to make happy compounds, right? Well, I've already got one nitrogen. What I need to do is add a beryllium. Okay, so I'm going to add the other one that's unhappy still, other than the one that's already that's unhappy. Okay, so this one's still unhappy. I'm going to add a beryllium to it. Well, anytime I add a beryllium, it's always going to start with what Louis dot structure? It's always got to start with a 2. Right? So, what will that electron do? Give it to nitrogen right there. Did I just make any one of those happy? Which one? This first nitrogen, right? So, happy brackets. Now, how many arrows are going into nitrogen?
3.
Which means it's accepted 3 electrons. So what does its overall charge need to be? 3 electrons. Its overall charge is going to be what? -3. And that should make sense, right? Nitrogen wants to gain 3 electrons, and so there we go. That should make sense, right? Are we done? That beryllium is unhappy now, is upset. So now, because I have the beryllium, what element should I add next? Nitrogen. Why am I only adding nitrogen and berylliums? Because that's what the question is asking. Okay? And we're only ever going to have to do 2. You'll never have like a 3rd or 4th element to add, right? So I need to add another nitrogen. Well, that nitrogen's Louis dot structure starts with what? Always starts with 5. So now, what's going to happen? The beryllium's going to give that 1 to a nitrogen. And what do I need to do to that beryllium? Bracket. And then what? +2. Are we done? There's an end spot. It's not going to go on forever. It's not a repeating decimal, right? It's not going to keep going forever. So that goes there. But I have an unhappy nitrogen, so what do I need to add now? A beryllium. Going to do that. It starts with 2. 1, 2. Yes?
Yes.
Now, this one will take that spot, and this one will take that spot. And now, that completes nitrogen with a -3. And now that completes that beryllium with a +2. And now is everything happy? Told you there was an end game to it, right? But look how that looks like a huge mess, right?
Yeah.
And I told you it would like you wouldn't know what was going on if you woke up right now and looked at that, right? But if you followed along each step, it's not that terrible. Okay? So what did we just do? We showed how many berylliums it took to react and form a happy compound with how many nitrogens? So we go over to the formula to write this a little neater way, right? What is the formula that is needed for beryllium and nitrogen to react to form a happy compound? Well, what do we always list first? Metal. So which one's your metal? How many berylliums did it take?
3.
Nitrogen's next. How many nitrogens did it take?
2.
And there's your formula. So you're gonna, like, this is about as extensive as we get in here, okay? You'll have much quicker ones, and you'll have one about in between, okay? But if you can do this one, then you can do any of them that I give you, right? So what is the overall charge? Now, the goal is for it to be what? 0. Let's check. +2 in your head, -3. Then +2. Then -3. Then +2. What do we get? We all get 0, right? That means we have more than likely done all of that correct. Yes? All right, here we go. You get about a minute. You and your group have the next one.
Get back to.
All right, we're looking pretty good. Walking around. Looking pretty good. Okay? So, a couple things. Make sure, because the devil's kind of the details in this class, guys. Like, you miss enough details, and that's when our grades start to plummet a little bit, okay? The details. Notice how, did I draw any bars connecting the dots over here? Or are they all arrows? They're all arrows. Because if you remember from last lesson, a bar is shared electrons. So if you're just drawing like bars, like a line, you will get counted off, okay? Make sure you are doing arrows, because those arrows are a transfer of electrons. Everybody following that? And that's what happens in ionic compounds. It's a transfer of electrons, not a share. That's covalent. Okay? So we should have started. The next time, this is like some of you are going to be like, okay, I got this. I can do any of them that you give me. So from now on, if you got it, what I want to tell you to do is try to make these neater and plan ahead. This will be a very good skill for covalent, because you're going to want to plan ahead because of what you're going to be drawing. But here, what I mean by that is, if you know that barium has 2, right? Barium has 2 electrons, you know that they're going to have to get rid of it. So let's try to make it nicer so we don't have like figure 8 arrows and looping, snaking arrows if we don't have to. What do I mean by that? Right? Barium has 2, yes? Right? Fluorine only needs 1. So if I go fluorine, 1, 2, 3, 4, 5, 6, the first planning ahead is, look, does it matter the organization of my dots?
No.
This is okay, right? That I have my single one to the right, right? Now, if I put that single one towards my barium, now I don't have to loop up or loop around. You see what I'm saying? I just try to plan ahead a little bit to where I can just go straight there, and that takes care of that one, right? So that fluorine has become happy with a what charge? -1 charge, right? And now I know that I'm going to need at least another fluorine, right? I can see it when it clicks for you, and it'll click at different times for everybody. Fluorine, I can put this fluorine over here. 1, 2, 3, 4, 5, 6. Notice how I put that single dot facing barium again, so I'm not looping around and to the side and all that kind of stuff, and put it straight there. Plan ahead if you can, if you know what's going on. That takes care of that fluorine with a minus, and barium is now happy with a what charge on it? +2. Now, if you did barium, fluorine, fluorine, are you wrong? No, it just looks a little messier than probably that. It's okay. It's fine. Still right. You would still get it right on the test. Okay? Any questions there? So what's my formula? If I have, which one's my metal? Which one's my cation? Barium. How many bariums are there? One. My next is fluorine. How many fluorines are there? There you go. Now it should be 0, but we need to check to make sure it is 0. -1 plus 2, -1, add them together, you get 0. So we are almost certain to be right that I've done all those checks. Any questions there? Okay, go to your notes. Go to your notes. We're starting on the middle of page 2 because we've already been through a day. Sorry, half of a day. And it starts here. So this is where we're going to add to our definition of cations and anions. So a cation, and you're going to add some extra things to this. If you have your vocab chart out, that would be a good thing. A cation is going to be anything that is a what?
Metal.
Y'all listen? What is a cation?
A metal.
A metal. Now what you need to add to your definition is a little bit extra. A cation is going to be anything that loses their electrons, and more specifically, causes a positive ion. Yes?
Yes.
All of your metals over there will form a positive ion when they become happy. That's the new part. So now I'm not going to, like if I give you another vocab quiz, I may not say metals. I may say forms a positive ion. A little more difficult, right? But now you know. Yes? Here's why we needed to add that little addition. If I look at hydrogen, what is the Louis dot structure of hydrogen? Write it somewhere. Real quick. Good practice for you. What is hydrogen's Louis dot structure? Listen. Guys, quit writing what's up there. Listen to me. Hydrogen has a Louis dot structure of what?
No.
What does it want to do with that one dot? If it gets rid of that electron, what does it turn into? What's the ion? Yes?
Yep.
Why am I doing this? Because does hydrogen form a positive ion? Is hydrogen a metal?
No.
It's a gas. Right? So, here's an exception. Hydrogen is the exception to this whole metal, non-metal thing back and forth. Yes, all cations are metals, including hydrogen, because it forms a positive ion. Everybody understand why you had to add that little detail to the definition? Right? That's what you need to know. Okay? Now, anions are all going to be nonmetals. Okay? There is no metal that is an anion. That's a good thing for you. There's no exception to this one. Just to the cation and hydrogen. All right? They are all going to gain electrons to get to their octet. All right? They're going to gain, so they're going to form negative anions. Or negative ions, I should say, which is an anion. Okay, so this chart, you don't have this chart, but you have it in you have a chart like it in your homework. So go to page 3 again. At the top of page 3 is a chart just like this. Everybody there? The page that we were just working on. Now we're at the top of it. You ready? This is how. Most of you could probably figure this out without me directly telling you how, but let me just do one or two with you, and then you'll have a few minutes to work on it. Ready? Calcium. Is calcium, now mine's different than yours. Y'all see that? So just watch the examples and you can do yours. Calcium, is it a metal or non-metal? Calcium is a cation or anion? Cation. Number of valence electrons. How many valence electrons will calcium have?
2.
Put it 2. right? Will it want to gain or lose to become happy? Lose, yes. What will its overall charge be if it loses those two things? Plus 2. That's how it works. Now, be careful when you get to your anions. Let's do one anion, right? Bromine is a halogen, so it's got to be a nonmetal and an anion, correct? Am I going too fast? This is a lot of review. Number of valence electrons per bromine. How many valence electrons, Jarrell? Bromine. How many valence electrons? Bromine is a halogen. 7. Will it want to gain or lose to become happy? Gain?
Yeah.
How many doesn't want to gain? Maybe put that off to the side. Right? When it does gain 1, what will its overall charge be? -1. Yes? Your turn. Go. Fill out that chart on the top of page 3 of your homework. All right. So moving into the next part of this lesson, I want you to look at the example on your page, potassium. Everybody see it? That one's done for you. Look at its overall charge, and then I want you to look at lithium's overall charge. What do we notice? Everybody said they're the same? Right? If you look at, so I've got bromine up here. Look at my bromine charge, and look at your fluorine, F. Fluorine's charge is what? -1, and what's fluorine? They're the same, right? What am I trying to get out without just coming out and telling you? Families have the same charge number. Does that make sense? So if you look at your periodic tables right now, look at your periodic tables, and I asked you, what is the charge going to be on, let's say, rubidium? Now that you know lithium and potassiums are +1, what would you guess rubidium's is going to be?
Probably a +1.
Because it's in the same family. You all following that? Now that you know bromine and fluorine have a -1, what would you guess chlorine is going to be? What about iodine? Iodine's in the same family, right? You see what I'm saying? If I know that calcium is +2, what would you guess, or what would you know now, not guessing anymore? Destiny, what's going to be strontium? Destiny. Destiny. What's strontium going to be?
Sorry.
What's the charge on strontium going to be?
Strontium?
Mm-hmm. If calcium is +2, if calcium is +2, what's strontium going to be?
-2.
Calcium is +2. It's in the same family.
Oh, +2.
+2. There you go. What about beryllium?
+2.
There we go. Okay? What you're telling me right now is what we call oxidation numbers. All right? So if I go to the next slide, this slide tells you everything. It's in your notes. The next part is oxidation numbers. All right. Oxidation number, or oxidation, is just a fancy way of saying what charge will that ion make. All right, what charge will that ion make? So this is what I've told every other class. For the level classes that I've taught before, what I would do on the big periodic table over here, guys, pay attention, is I would put sticky notes of what the oxidation number is above each one that we knew. So all of your A columns. I don't do that for you, okay? Because we should understand where those oxidation numbers come from. They come from what does that family want to do to become happy. So if I were to put sticky notes up over here, and if you have your colored periodic tables out that you use to study and to use at home, what you could write, what sticky note would I put above your group 1? A +1. Yes? What would I put above alkaline earth metals? +2. And that's what I put. What about above halogens? What would I put above halogens? -1. What about above the oxygen family? -2. What about above the nitrogen family? -3. Would I put anything above carbon? No, because we don't know. +4, -4, we don't use those examples. Okay? What about above boron? Okay, stop. Y'all don't know? That's fine. That's perfect. Because you need to know where they come from. Do the Lewis dot structure for boron right now. Everybody, real quick. It'll take 5 seconds. Y'all can do the Lewis dot structure of boron. What's it want to do? It wants to get rid of what? 3 electrons, which means its overall charge is going to be what? Plus or minus 3. Which one? It's getting rid of electrons. +3. Yes? You just figured out that family's oxidation number. Because listen, why is that important? It's going to happen on your test where you're like, I don't remember what the oxidation number is. Do a Lewis dot structure of it. Figure out what's going to do to be happy. That's its oxidation number. There's a reason why I'm saying this, because we need those oxidation numbers for what we're about to do. Okay? So why is that important? We're going to skip through this because we are about to name and write ionic formulas in compounds. This is the brand new stuff for today. So when we go to write, we have specific rules. Writing compounds is easier than writing formulas. Okay? There are specific rules that you need to pay attention to, and they're not hard, but spelling is going to count. It has to, because we're changing the name of something. If you don't spell it right, then you're not showing that you know what the rules are. Okay? So, the first thing that you got to know is that an ionic compound is a bond between a metal and a nonmetal. These rules only apply for metals and nonmetals, because when I have nonmetal and nonmetal, they're different. Y'all follow me? So these are the rules only for ionic compounds. When we get to covalent, you got to learn a new set of rules. And actually, when we get to acids, new set of rules. Okay? These are for ionic. You ready? The easy part, the easy way. So, how this works, I give you a chemical formula, like NaCl, like LiBr, like CaF2. These are chemical formulas, right? From the chemical formula, you have to write the correct name. So this is naming compounds. You ready? This is fairly straightforward. What you would write, I say, name that thing. You would say, well, Na is what?
Sodium.
You write down sodium completely, no change. Give a space because it's 2 words. Then that thing, Cl, is what? Chlorine. So instead of the first real rule, instead of writing chlorine, you drop the last syllable and replace it with ide. So now this turns into not sodium chlorine, but because it's an ionic compound, it turns into sodium chloride. That's it, right? So this next one, lithium and bromine, I wouldn't say that if I said, what is that thing? If you're reading it in a sentence or in a book, you wouldn't say blah 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 lithium bromine. You would say lithium, drop the ending, mine. Right? The next one, calcium. Write it out completely. Leave a space. That is fluorine. Fluorine turns into fluoride. Spelling counts. It's not flouride. It's fluoride. UOR. Okay? Everybody got that? The biggest mistakes that I see are with like sulfur. Because what some people want to say is sulfur I. Well, what did they not do there? What did this person not do? You didn't get rid of the ending. So this turns into not sulfuride, but sulfide. Everybody got that? So make sure you're dropping really the ending and then adding the IDE. Okay? So go to page 1 of your homework. Page 1 of your homework. The top of it is turning formulas into names. That's what you're working on right now. You got about 3 minutes to get as many done as you can. There's really no curveballs today with this skill, turning formulas into names. Go ahead and work on that for about 2 to 3 minutes. All right, so is there any major concerns about the naming formulas part? Okay. Any questions you want me to cover? It's really about how much you cut off at the end. That's always the biggest question. How much or how little do you cut off at the end? That's just getting a feel for it. The major one, the big one is phosphorus. And don't leave sulfur. It's not sulfuride, it's sulfide. Okay? So this is the hardest skill of today. Now we're going from the name into the formula. So now the numbers matter, right? It didn't matter if you had Mg2F, right? We didn't really worry about that 2 in the name, right? We didn't indicate a 2 in magnesium fluoride. Y'all following me? Or just worried about what to write down? You hear what I just said? Doesn't sound like it. When I go to write this name, does that 2 come in the name at all?
No.
It's like di or 2 magnesium fluoride, right? That we don't worry about those subscripts when we go from the formula into the name. Now when we go from the name into the formula, we know that those two magnesiums matter, right? So we have to find out where those 2's come from. So these rules up here are going to be extremely important, okay? Because you will guess on some of these where you think you got it right, but unless you follow these rules, you will not get 100% of them right, okay? The pattern that you think you got doesn't always hold true unless you follow this, all right? So, yes, I realize on the next slide coming up, there are some blanks that you're going to want to write in. Please follow me and do exactly what I do. If you miss out on what I'm saying right now, you're going to miss the entire concept of this part of the lesson, okay? Here we go. Don't copy those down yet. Follow me. Good. Got everybody's eyes. We are trying to go from aluminum oxide into the formula. I give you the name. You need to write the formula, okay? Now, the first thing is you're thinking aluminum. Well, that's a transition metal. Well, we don't work with transition metals very often. Well, now is when I tell you over here, I know it's kind of be hard for y'all to see it, so you might want to write it down, that there's what we call the exception block in your transition metals, which means it's these, if you can see the colored tape over there, there's 6 of these over here that are in colored tape. They are an exception to your B block metals, which means we know their exact valence electrons all the time, okay? The good news is that aluminum, gallium, and indium all fall underneath boron. If you can't see it, look at your periodic table. Look at boron. Underneath boron is aluminum, gallium, and indium, right? Well, what is boron's oxidation number? We just did it. What's boron's oxidation number?
+3.
+3. And now that I tell you that aluminum, gallium, and indium fall in that same family rule, what is aluminum's oxidation number?
+3.
Everybody see that? Yes? Okay. So, that way to get that out of the way real quick. Write the symbols metal first, right? So, I want aluminum oxide into a formula. Aluminum symbol is what? Write down Al. Oxide comes from what? Oxygen. Write down oxygen. That's step one. Not too difficult, right?
Yeah.
The next step, which is why we hit so hard on oxidation numbers just a little bit ago. Above each symbol, write the oxidation number. What's the oxidation for aluminum? We just said it. Plus 3. What about for oxygen? What is it? Minus 2. And do you know where that minus 2 comes from?
Yes.
The Lewis dot structure. What's going to make it happy? Getting rid of 2 or gaining 2 electrons. Yes? Step 3, pay attention. This is the difficult one. Not difficult, but confusing. It says add subscripts so that the overall charge of the compound is 0. What? Don't worry about all that. You read crisscross the charges. What does that mean? Take that 3. Now is not the time to doze off. Take that 3 and give it to oxygen. Take that 2 and give it to aluminum. That's where crisscross comes in. And the little side note is erase the charges. Those charges go away. It's not magic. I'll tell you where they went in a second. So now this turns into what chemical formula? Al2O3. Do I need to re-say that or redo that? This is the shortcut to the Lewis dot structure way of doing it. All right? What do I mean by that? Because remember how I said, what does every single compound that we make in here has to have what overall charge at the end? You guys remember doing that in our homework? So this has to have an overall charge of 0, right? Well, you're saying, well, look at those charges. Those charges indicate what? An overall charge of what? Of 1, but it's supposed to be 0. So where did all this go? Why do those charges disappear? Here's why. If I would do the Lewis dot structure of this, right? This is the shortcut of crisscrossing. What if we didn't know about the crisscrossing method? Well, then we go back to the Lewis dot structure. I know that I start with aluminum, 3, and oxygen what? 6. You all follow me? We're almost done. Right? To complete this, aluminum would go there. That that electron would go there. Yes? That's become happy with minus 2.
Yeah.
Right? Not happy. Another oxygen. 1, 2, 3, 4, 5, 6. That can be put there. Now that's happy with a. Oh, sorry, and then there's another one. No, we're good. Plus 3, yes?
Yep.
Not happy. Aluminum. 1, 2, 3. Put it there. That's happy. Minus 2. Happy or unhappy? Get another oxygen. 1, 2, 3, 4, 5, 6. And then here we go. There. That's become happy with a plus 3. Happy with a minus 2. We did that at the beginning of the class, right? So me going fast shouldn't have been that big of a deal. You all know how to do that.
Yep.
Okay? However, why did I do that? This is the long way of getting to this. How many oxygens do you see here?
3.
How many aluminums do you see here?
2.
And all of you that said, and you were right, 3 plus negative 2 is 1. Why do the charges automatically disappear when we bring them down? Because when we have the right charges on all of these, plus 3, minus 2, minus 2, plus 3, minus 2, if you don't believe me, do it in the calculator, do it in your head. When I add up all of those charges, what does it come out to be? 0. So that works. Okay? This method proves why we are able to crisscross those charges and come up with a valid chemical formula. Everybody kind of get that? Right? So let's start with oxidation. Start with by writing down the symbols. Oxidation numbers above them. Cross them up. All right? Go to your homework. The bottom of that same page, of page 1, is what we're doing. Now, I'm going to go through 2 or 3 of them with you right now because there's some curveballs in there that you need to be aware of. Back to the top. So, please watch. Number one, sodium chloride. Write down the symbol, sodium. Sodium has a oxidation number of what?
1.
Positive 1, right?
Yep.
Chlorine has a oxidation number of what?
Negative.
-1.
Yep.
What am I doing with those oxidation numbers?
Switching.
Cross them up, take them into the subscript. Subscript's at the bottom. Na1Cl1. Why would I count that wrong?
Because you don't need the
Do I need those ones?
No.
They're implied, right? So that's why you always see it as NaCl.
Yes.
Just to backtrack real quick, why are we using these rules? Because this is an ionic compound. What makes it ionic? Cation and anion. Yes? If it were anion, these rules wouldn't apply. You will learn those rules later, but we'd have to learn those before we could do it. Okay? If I come down here to number 2, here's a little bit different. Magnesium fluoride. Magnesium has a charge of what?
2.
Magnesium has a charge of what? Positive 2. Fluorine has a charge of what? -1. What do I do with those charges? Cross them up. So now I have Mg2F. Does that make sense? Mg2. Is that right?
No.
Is that right?
Not MgF2, right?
That is wrong. What is it?
MgF2. God, I'm so crazy.
MgF2. Is that better? You are all going to make that mistake at some point in this unit. You're going to put this up here, and you're going to be thinking, like, I got it, we're good, this is easy. And then you're going to put Mg2F. You didn't cross them up. Slow down, right? The last little curveball. Go to number 7. Everybody go to number 7. Everybody should be on number 7. Ready? Mg has a positive 2 charge. Yes? We just did it. Oxide comes from oxygen, which has a -2 charge. Yes?
Yep.
Wait. Did you say wait? No, you're good? Everybody good?
Yeah.
So why is Mg2O2 incorrect? They cancel each other out. Those 2's cancel each other out. So what am I saying? You have to have your most reduced subscripts. Yes? Those 2's can get, now it's always going to be like a 4 and a 2. You'll really never have a 6 and a 3 that you reduce. Okay? There's always going to be a 2 and 2 or a 4 and a 2. In this case, it's 2, 2, so my answer should be MgO. And so you should be thinking, some of you might not be, but some of you should be, like, what about all of this over here? What about will I draw Mg twice and then oxygen twice and then have to reduce? No. If I asked you magnesium and oxygen react with each other, show them the Louis dot structure, you would do this, or you should do this. Mg has 2, right? Oxygen has 6. Fill there. fill there, both become happy. How many magnesiums do I have? How many oxygens? Which explains why that is your answer, yes?
Yep.
Why we reduce, because that's what we need. Still has an overall charge of what?
0.
Plus 2 minus 2?
0.
0, okay? All right. I'll give you 1 minute to maybe do 1 or 2 extra practice, and then we got to get to the Kahoot.